Hello, my name is Steve Samuel from Design Visionaries, and today's topic is industrial design surfacing. And it happens that NX has some incredibly powerful tools to do industrial design surfacing quickly and efficiently. And I will today go through some of those tools, a very small fraction of those tools, because if I went through all of them, I would be here for months. Anyway, I have here a case study. As you can see, there's a transducer. People call it a speaker, but there's a transducer that requires a housing. Industrial design surfacing, in many cases, is best done when you have a really good set of components that you are going to be adjusting the surfacing to. And you start off with those components and in an assembly so that you know exactly how big the design has to be. In this case, we have enough space for the transducer. We have enough space for the base box. There's going to be circuit boards and all kinds of stuff. So we have a basic size. It's about 11 inches high, and it needs to be about 10 inches wide. So as you can see, what I have here is the surface analysis, the curvature analysis on these surfaces, and it's transparent. So having done that, I'm going to now just do a brand new part file to show you some of the techniques that I used to create the housing. Okay, so I love to start things off with a sketch because sketching allows you to change things so quickly. And for this particular exercise, I'm starting off with an equilateral triangle. That's always a shape that people can relate to, and I know that it's going to be 10 inches across the top. So I'm going to put a dimension on here, 10 inches. There's 10. Yes, do that much. Then I'm going to make sure that I've got some rules here. So for example, I would like equal length on these members of the sketch. I need my automatic selection progression on. I didn't do it automatically, so that's good. I need there, thank you, that's good. I need horizontality here. As you can see, I have the create persistent relations turned on. That's my favorite mode. I want to center this little point there, or center the shape about that point. So I put two of those on there, and I don't need more than that. This one. Go. Okay. Now I have a shape that's going to drive everything else. These members here can be referenced. So, and what I'm going to do now is place arcs on the shape, and this is going to be the arc of the front face. So I need a dimension from here to here. That's going to be 1 inch, and I need another arc from here to here, and that is going to be 1.5 inches. Here to there, 1.5, good. And then I need to mirror that over, mirror that from there, about this there. And there I've got the basic shape of my housing. Now, if I just extrude that housing 11 inches, it's not going to look good because I want it to taper as I go. And when I mean taper, I don't want it to just tilt. I want it to have some shape to it. So in order to achieve that, I'm going to do another sketch, and I'm going to control it with a sketch. And NX has some tools that I just think are fabulous, so easy to use. And you'll see what I mean in just a second. So here's 11 inches. That, okay, and I'm going to make a line out here I'm going to make another line out here, and this will make sense in just a moment. There's going to be an arc from there to there. So, and I'm going to put a perpendicularity between line and arc. That. I'm going to put a dimension 32 there. And I'm going to put another dimension from there to there, 6. Okay. All right, now this shape is what I'm going to use to now drive this curve to the right shape. And I'm going to do that with one of my favorite surfaces. I'm going to use the swept surface. And the swept surface is so powerful because you can have a section like that be driven along a drive curve like that. Okay? But you can use a shape to control its perimeter. So in the scaling method, you can do this thing called the perimeter law. Love it. And the perimeter law that I'm using is something called a by-law curve. So the by-law curve has a baseline. This is the baseline. And NX is marching up this baseline. And then it's going to ask this curve right here to regulate the perimeter of this shape. So when I select this curve, no, why? Let's see. Baseline, law curve. Oh, so let's do this. Let's deselect that. This is the law curve. And the baseline is this one. Oh yeah, it did it, see? So it cooperated. Now, what I need, as you can see, it's got a nice little taper on it. Very interesting taper because it's being driven by this curve. Okay, now what I need is at every single edge, I need a sharp corner because that sharp corner needs to be blended. I want a G3 curvature continuity blend at each corner. So I have to have this preserve shape on. The significance of preserve shape is that if I don't have preserve shape, I'm not really getting a sharp corner. I'm not getting the surfaces to be commensurate with the sections of the section, or the segments, I should say segments of the section. When I don't have preserved shape on, what the swept function is trying to do is make this whole surface one smooth surface. So it has a sharp corner there, but it doesn't have a sharp corner here, as you can see if you really zoom up. That means I can't put a blend in there. Okay, but when I hit the preserve shape switch, as you can see, now it pays attention to the segments in the actual drive or in the actual section. So there you have it. Preserve shape is a really important thing to understand. What you can also see is that my surface is not really conforming to the curve or the section that I started with. Why not? Because my law curve is based on 32. I just approximated that. And the perimeter of these entities is not exactly 32. So if I want it to match up, I need to go back and I need to do a measurement. So I'm going to do an analysis, measure, and I'm going to do something smart here. I'm going to go into settings and I'm going to make an associative measure. And I'm going to measure the curve length of this section. The way I'm going to do it is by selecting Object Set and selecting Connected Curves. Excuse me. And the connected curves will be these curves here. There we go. It says the length is 31.4438. If I want this to be perfect, a perfect match, I need 31.4438. And when I have this associativity switch on and I say OK, then I get an expression that shows me, here it is, P12 is 31.443376, whatever. And I can now change the, I can change the name of that expression to length. Say apply. And the fantastic thing about NX now is I have created an entity, a measure curve entity, but it has created an expression. And now I can go back to that original sketch, and I can type in, instead of 32, I can type in length, the measurement expression, and it says, oh, we're getting a, it's not going to be able to use it because it's a quote-unquote later timestamp, but that's okay, because what I can do now is take that measure curve entity and push it right there before the law curve. Good. And now if I go back to that sketch here, type in length, and hit enter, and now it is 31.4438, just like it has to be. And that is incredibly powerful, the fact that you can do that so effortlessly. So now I am driving the section with the length of my law curve. And if I want to change that section, actually, I'm sorry, a little correction. I'm not driving the section, the length of my law curve. I'm driving the law curve with the circumference measurement, or the perimeter measurement of my section. So if I should change the section, I would hope that this piece of geometry changes also, and then I still get the ability to taper this thing any way I want, or as much as I want, as I'm driving it. So let's do a little test. Let's go back to the original sketch. The original sketch had a dimension, here it is, 10 inches. And if I change that to 12 inches, let's say, 12, then the whole section, of course, updates. And also, this drive curve thing changes with length. And as you can see, what I've driven, the piece of geometry that I've used, that I've swept, is now updated as well. Okay, so that's an incredibly powerful way to work. I know it's kind of mathematical, and this is an industrial design piece, and a lot of folks who do industrial design don't necessarily like to use these methods, these mathematical methods, but I find it incredibly powerful because now I can make such easy changes. For example, I'd like this to taper a bit more than it is, and so I can just go to this law curve, and I can say 8 instead of 6, and as soon as I say finish, or if I say update model, you can see how that is now tapering top. Just do it a little bit more, go to 10, and say update model. And so as you can see, it's tapering. That's too much. I really like that, so I'm going to go back to 6. And a lot of industrial design, in my view, is a judgment call. It's just based on your, in many cases, it's based on your feeling. And I have decided that I wanted this face to be flatter than these faces. So that's why in my original sketch, I have the offset from this basic triangular shape, be 1.5. This is 1. I think I'll make it a little bit flatter, however, at 0.6. It's going to be flatter. So that will accommodate the face of that transducer a lot better. There we go. And as you can see, everything updates quite nicely. Beautiful. Okay, so I don't need to see those sketches anymore, so I'm just going to hide those. And now I'm going to go about the business of softening these curves. And I have decided, as the industrial designer for this particular project, that I really want the, I don't want these sharp edges. I want them to be smooth, and I want them to look like something that grew out of the ground, and something that's just really soft. And so I've decided to use a blend called an aesthetic face blend. Aesthetic face blend. It is incredibly powerful because you can adjust the continuity, and G3 curvature continuity is great, because what happens with a G3 flow curvature continuity is it takes longer for the shape that we're creating to transition from what it's touching to the full curvature. So instead of having this abrupt arc there, you're going to see something different that is a lot better and looks a lot smoother, a lot more professional. So for the aesthetic face blend, and I'm going to do the aesthetic face blend, and I'll do a lousy, just regular edge blend, then we'll compare them and I'll show you exactly what I mean. So in order to do the aesthetic face blend, there's a lot of little presets here and things that you can change. But one of the best ways that I like to use it is with the RHO, row, and that's a measure of how quickly it will go to from curve to straight. And I have a preference of row at 0.65. That's something that is just my personal preference. So if I show you, what I'll do is I'll select face number 1. There it is. I'll select face number 2. There it is. I'm going to arbitrarily select a radius that it's based on, which will be 1 inch, just like that. As you can see, it's on G3 flow. I've got all these choices. I've got G0, G1, G2, G3. G3 for me, for this particular project, is going to be the best with an RHO of 0.65. And I want to go to the trim functions, and I want to trim body to blend, and I want to sew all faces. So it does a nice job of, when I hit apply, of making this nice smooth transition. Fantastic. Okay, I'm going to do another one on this side. I'm going to do not tangent faces, but single face here. My second set is also going to be single face, like so. I'm all set up for RHO 0.65, blend radius 1, G3 flow, trim body to blend, sew all faces, say OK. And that looks really great, so I'm concerned. Now I'm going to do a regular edge blend, a G1 curvature continuity edge blend that is circular. I'm going to put it on here. It's going to be based on radius 1 and say OK. And now let us do a surface analysis and see exactly what happened. So I'll go to Analysis, Section Analysis. I'll select these tangent faces, all the ones that are around the periphery. And as you can see, the blends, the aesthetic face blends, they go from the curvature that we have, the natural curvature that we have on that face, which is constant, and they gradually change from the radius of curvature of this flattened radius of curvature to what we need to get all the way around to the other side. And as you can see, there's a really nice smooth shape on that. So that means the light that bounces off of it is going to be smooth, and it's not going to reveal exactly where this blend starts and where it ends. And it's going to look much, much better as a actual piece that's sitting on your desk. You can actually pick that up with your eye. And as you can see, the edge blend that I used, really abrupt. It goes from the curvature of the sides, which is constant, and then suddenly up to there. And that looks terrible. So that's what industrial designers know, and that is really an important concept. The curvature continuity of surfaces when they come together. And so I'm going to take that edge blend away. Let's get rid of that, and let's now replace it with a nice aesthetic face blend. Aesthetic face blend, as I said. Let's take a look at the ramifications of rho. So I'm going to put this at 0.6 now, a 0.6 RHO. and I'm going to use the same base radius and the same G3, the same trim body to blend. I'll select this face this time and this face and say OK. And as you can see, I'm getting a smooth transition, but it looks a little funny in the as it goes. It's not exactly a constant drop off, and so that RHO to me is not as good. Such a minor difference, but it makes such a big difference. So let's try a few different RHO values. So if I say a real small one, 0.2, okay, here, then it looks really weird. It looks almost like a chamfer, really flat. And obviously, it's not going to look good. Let's go back to it. And let's do an RHO of 0.9. Okay. And that's like really pointy. It's almost like no blend at all. And so it's personal preference in the end. That's why, in my experience, 0.65 really does the nicest job. Thereabouts 0.65. It depends on the actual shape, etc. So there you have it. And now, this surface analysis, we can take that surface analysis and just not hide it. We can just keep it so that we can bring it back later. The very next thing I will do to complete my industrial design is I'm going to extrude the face edges of this bottom face. And I'm going to go 0.5, but I'm going to do it with a taper, a draft section. I'm going to give it 20 degrees. And so that's nice how it will kind of bring that down into the, ignite that all up. Go. There. So there's my industrial design. I think I want to do one more thing on the top. I'm going to do another extrude from face edges. Only this time I'm going to have an offset, single-sided offset of minus 0.125. And I'm going to have a 0.125 height on this thing. And I'm also going to put a draft on it. I'm going to draft it from the section. And I'm going to draft it in such a way that it kind of matches the final angle, run-out angle of my surface. It looks like that's going to be about, I could get it perfectly, but I think by eye, we're talking about 17 degrees or 15 degrees. There we go. 15 degrees. Beautiful. So there's my industrial design. And the great thing about NX is this is my industrial design. But you can't mold this. This would typically be an injection mold. An injection molded part, which would have to be molded from the bottom. You'd have to have this as a separate part. You'd have to have a core and a cavity, and the cavity would probably be this whole shape, and you'd core it out. And so the cool thing about NX is it has such a powerful set of tools for industrial design. I'm going to save this, and I'm now going to go into assemblies. And in assemblies, I have the ability to do interfaces, product interfaces. So what I need to do now is make this piece a separate piece. That's going to be like the bottom piece. And that will screw onto this piece, and this will have screw bosses and some way of getting that speaker in there and sealing it up, and there'll be screws on the bottom, and there'll be little feet and so on and so forth. And so just quickly, to finish this little exercise off, this industrial design exercise, I'm going to go to the split body command, split body. I'm going to take the body that I've created, and I'm going to split it with this bottom datum plane. Okay. So now, as you can see, if I put a different color on the bottom, you can see it's indeed a different different piece of geometry. Great. Perhaps I would have this piece be a cover that would be snapped on as well, so this whole thing would be hollow. So I think I'll do it one more time. I think I'll go to the split body command. I'll select this body, and I will do a new plane that just resides on this little top face right here. Say okay. So now I've got this body here, and I'll just color code that. I've got 3 bodies, and these are all in one part file, but I want an assembly so I can continue in a really good way for a group of us to be modeling in. And you know, a lot of these projects are done by many people working in concert, and so the industrial design of the speaker is all captured in this one part file. And then I can go to the assemblies, and I can go to the interpart links more and find product interface. And product interface, I can do this. I can click on that little body, and I can do interface properties and call it the main housing. US main housing. Okay. Click on new, and I'll select that body, and I'll call it the top case. Okay. And I'll do new and select on this body, and I'll call that the base, like that. Okay. So now this part file will be the part file that drives everything else. And certainly if we house the speaker in there, and we put the circuit board in there, and the bass box, and all the other electronics and controls, and we find that it's too big or too small, we can easily go back to the original sketch and make one change, and everything will change commensurately. Let's test that out. So I'll go back to the original sketch. Here it is. The original sketch was controlled basically by this number, and let's make it 8. And so at 8, everything changes, and look, it's now taller and thinner. And as you can see, the blends are back. My different bodies are here. So with one change, I can size this so easily. That's the beauty of using a product like NX, where you can do industrial design, and you can have such great control of surfaces, but you can control them in a way that gives you this amazing ability to do design iterations. That's extremely valuable to me. Okay, to finish off, we have the product interfaces, right? So if you take a look at product interface, you have the base, you've got the main housing, you've got the top case, we've got the transducer. Okay, I just did a Control Z to get it back to the right size. And now to finish this little demonstration off, I'm going to do the final little assembly. So I'm going to have a part file called base. I guess I already used that name. I'm going to call it demo base. So there's a new part file called demo base. File new. There's a part file called demo housing. Okay. There's a part file called demo top case lid. What did I call it? Top. It's going to be demo top now. Okay. And when I go to the demo base, and I open that part file up, I simply go home, more. I go wave interface linker. I pick up the part that has all the goodies in it, and I bring in the base. Demo base, right? Go. Say okay. And there's the demo base. The demo base needs some shelling. There we go. Let's make it 0.125 wall thickness. Say okay. And it would have the screw bosses and the different goodies, and I would probably work a while on that and the reveal and how it interfaces with the housing. So anyway, let's go to demo housing. Let's do the same. File, more, wave interface linker. Pick up the part with all the interfaces on it. Go main housing. Say okay. there's that. This one wants to be shelled out from the top to the bottom. Okay, so now that is actually moldable, but it would have other goodies in here, other screw bosses and different. We'd have to make provisions to bolt the transducer to the face. We'd have to have a nice little opening for that and all of that. So this is just the start of this project. Oh, when I did the shell, probably should not have shelled this side, because we have to have a shoulder for the lid to be on. And so now I'm going to do an extrude face edges, but I'm going to do a single-sided offset, and I'm going to offset it by minus 0.5. I'm going to extrude it like this and do a subtract. So there we go. So there's a nice lip for the lid or the top to reside upon, the speaker lid. Okay. And then finally, let's do the okay. So what I need is the demo top, and in order to do that, I file more, wave interface linker, Z, top case. There's the demo top. Great. So now I've got all three components. I don't have the interfaces that hold them together and the screw bosses and all that stuff. That's you know, it would take me a while to do that. But as you can see, I can do the final assembly. And the final assembly I'm going to call final assembly. Final assembly. Okay, the final assembly, I'm going to say assemblies, add component, and I'm going to add the demo base. I'm going to make sure that the scatter is off. See, scatter. Take that off, because I want to do the demo base. And I want to hold my finger on the control key and get the demo housing and get the demo top all in one fell swoop. Oh yes, and the transducer. Get the transducer in there. There we go. And I'm going to say okay. So now all the parts are in. All the components are there. Of course, the transducer is not in the right spot. But now that I have them there, I can Control J, this transparent for the moment. Okay. And let's go in and move component. Grab this component here and orient it the way that we would need. And then we can experiment with the orientation of this and we can get it so it's perfect. That, I like that. I want it to be tilted a little bit with the wall. As you can see, it's snapping in a way that's stopping me from getting it perfect. So I'm going to click on this little BB here and give it a snap angle of 0.5, so there's better resolution. So now I can that is perfect. You have it. So now that I've positioned this the way I want to, I can start creating the different features in the housing. House this just right, and I can make the hole and put a grill on there, and that will be the topic of future speeches, future videos. Okay, so enough for now. This has been a long video, but you can see there's many techniques that are here that enable you. They enable you to do iterations and really get the geometry right first time, so that you have a really streamlined process and you can get your product on the market a lot faster. That is incredibly important. It's incredibly important that you have control over the surfaces, the curvature, the ability to create them and shape them and change them. If we suddenly go to, let's say, a larger transducer from another company, we might want to size the whole industrial design and just really keep tweaking it, and the ability to do it as quickly as this is incredibly important to me. Again, my name is Steve Samuel. Thanks for watching. It's a very long one, and I hope you appreciated it. I hope you like and subscribe, and tell about, like I said in previous videos, all about 1,000 of your closest friends. Thank you very much. Have a great day.